Hello everyone and welcome to the lecture on kubectl, taints and tolerations commands. So first we'll set the alias k equal to kubectl. So first topic is taints, tolerations and node affinity. So here I'll explain about the taints, toleration and node affinity. So we start with the taint, which is like a lock that is applied on a node. So when we apply a taint onto a node, it's like putting a lock. Then we have the toleration, which is like the key. So to open the lock, we need the key, and the key is applied onto a pod. So if pod has the toleration, it will tolerate the taint. So it will be able to open the lock and be able to run on that node. But this does not guarantee that pod will be able to run only on this. It may run on other nodes which may not have any lock. So it may go here. For example, if we have two nodes, it may go to a node with a taint or it will go to a node without a taint. But to guarantee that a pod goes to the tainted node only, we have the third, which is called as node affinity, which is like a magnet. So this key, which is a toleration, the magnet, which is affinity, will guide it to go to the tainted node. So this will make sure that we have a dedicated node pattern. So we have standard node, which can go on to a specific node, which will go to a tainted node, and it can go to dedicated node by affinity. And then standard pod may go to dedicated node, which is like a tainted node, or it may go to the other nodes. And this is how the Kubernetes scheduler decides where the pod will go based on these three things. So I'll explain more. So a taint, as I talked about, applied to a node. Taint is like a lock which is applied to nodes. Once the taint is applied to a node, only the pods which have the toleration, which is the key for that taint, can run on that node. Second, as I talked about, tolerations applied to a pod. Toleration is like a key which is applied to pods. Once a pod has the toleration, it can run on a node with a toleration. It can run on a node with a taint, I mean to say. This also means a pod with a toleration can also run on untainted node. So same way, a key can open a locked home, but also it does not need a key to open an unlocked home. So after we have taints and toleration, so tolerations will allow a pod to run on a tainted node, but also untainted node. Now, but to create a dedicated node pattern where a node is reserved exclusively for specific nodes, we need node affinity. So node affinity, which is the third thing, is applied to a pod. Node affinity is like a GPS or a magnet that directs the pod to a specific label. So this depends on node label. It works on node label on a node. While a toleration allows you to enter a locked home, it does not stop you from walking into an unlocked home instead. Node affinity fixes this by strictly guiding the pod. And there are node affinity rules like required during scheduling, ignored during execution. So this is a hard rule, and it says that go only to the home. Let's say this is an example. Go only to the home with address blue house. If you cannot find it, do not run anywhere. So the pod will go into pending state. Next one is preferred during scheduling, ignored during execution. So this is a soft rule. So this says try to find a home with the address blue house, but if you cannot find one, settle for any other available home. So next is the taint structure. So this taint structure is on the node side. So here a taint consists of three components: a key, value, and an effect. First one is a key, which is a string up to 253 characters. It can optionally be prefixed with a DNS subdomain, for example, example.com/GPU. It must begin and end with an alphanumeric character and allows hyphens, dots, and underscores. Next is the value, which is an optional string and can be up to 63 characters. And like the key, it accepts alphanumeric characters, dots, dashes, and underscores. And lastly, we have the effect, the specific scheduling behavior triggered by the taint. This field is strictly an enum with three possible values. So I'll talk about that also. So three type of taint effects. Those are the values. The choice of effect dictates the strictness of the constraint. So we have three effects. First one is no schedule. So this is impacted during which phase? So during the scheduling phase. So this is a hard constraint. The pod will not be scheduled on the node unless it tolerates the taint. Existing pods are unaffected. This is most common in certified Kubernetes administrator or application developer for specialized nodes. Next effect is prefer no schedule. This is also impacted during the scheduling phase. This is a soft constraint. The scheduler tries to avoid the node. If no other node is valid, the pod may be placed here even without a toleration. This is used for soft dedication or overflow capacity. And lastly, we have no execute. This is during execution phase. So this is the eviction trigger. It affects both pending and running pods. And if this is applied, untolerated pods are evicted immediately. And this is critical for certified Kubernetes security specialist exam, for quarantine, and for the admin exam for the maintenance tasks. Next is the toleration structure. This is the pod side. Now we have come to the second part, the pod, and so the toleration structure. A toleration in the pod specification mirrors the taint, but adds logic for matching. Right. So we are trying to match two things. So this is the second part. So a toleration, first it has a key, and this must match the taint key. So toleration key must match the taint key. Next one is the value. This must match the taint value. So there is an operator, which is if operator is equal. So third one is operator. It controls how the key value comparison is performed. So first one is equal, the default value. So here the key and value must match exactly. Next operator is we can either go for equal or exist. So this one matches any value for the given key. This acts as a wildcard for the value field. And then we have the effect, and this must match the taint effect, right? So we have it. So these all must match one by one. And if empty, it will match all the effects. What we have seen, three effects, right? No schedule, no execute, and preferred execute. So I'll just go through. Prefer no schedule, right? Okay. And lastly, we have the toleration seconds, and this is only for no execute. This defines how long a pod stays bound to a node after the taint is detected. So basically, this is a grace period. So next I'll cover the how to add a standard taint to a node. So we'll issue this command k taint no, or you can say the whole node, and this is the node name node 01, and we are applying this taint keys environment env, and the value key value, so prod, and the effect is no schedule. So to mark node 1 as reserved for production workloads, so this applies a taint with key env, value prod, and effect no schedule. Any pod without the corresponding toleration is barred. So anyway, as soon as you run this command, pod will not be scheduled. So you have to apply the toleration later. So you will get immediate output. You will see on the screen like that node 01 is tainted. And this will backend YAML will be having node information updated with the specification where you can see the taints, effect is no schedule, and key is env, value is prod. Next is how to add a key only taint. So we'll omit or skip the value. So we'll run this command k taint no node name, and here only key. So key, there is no equal to maintenance, and effect is no execute. So here the value component is optional. So in many exam scenarios, especially regarding maintenance, a value is unnecessary. So here you note the absence of the equal to sign. The key is maintenance, and the value is empty, and this is both valid and common. Next is how to update or modify a taint. So you'll run this command k taint no node name env prod no schedule, and we are saying overwrite. So here overwrite is important. So if you attempt to modify an existing taint, for example, changing the effect from, let's say, prefer no schedule to no schedule, here we are previously it has no prefer no schedule, now we are making it no schedule. The command will fail with an error stating that taint already exists. So in this, that's why you must use the dash dash overwrite flag here. Removing a taint, so you'll issue this command k taint no node key value and the effect and just a minus at the end. To remove a specific taint, you must specify the key value and effect exactly, followed by a minus sign. This removes only the taint that matches all three parameters. If env equal to prod no execute exists, it remains. So wildcard removal by key. So you can issue this command k taint no node. So we are removing all the taint just by the key. So in exam scenarios involving cluster cleanup or resetting a node, you may need to strip all the taints associated with a specific key, regardless of their value or effect. So this will remove everything, doesn't take into consideration the value and the effect. So this powerful command removes all, like env prod no schedule, env dev no execute, env prefer no schedule simultaneously. It is highly efficient for resetting a node. Then tainting by a label. So you can taint nodes by label as well. So k taint no, and this is dash l. This is like a label selector. So we are targeting all the nodes which has GPU equal to true, and then we are tainting it. This is a taint value, dedicated key value is ml, and the effect is no schedule. So this command finds all nodes with the label GPU equal to true and applies the taint. Next, I'll just cover tainting, how to taint all nodes. So this is there's a warning. So k taint no, and you can just say dash dash all. So this will target all the nodes, and we are just putting a taint. We are saying restricted equal to true and no schedule. So this can be anything, but this is just like have more meaningful text or the label. So this targets all nodes including the control plane. Since control plane nodes often have existing taints, the output may show modified for some and tainted for others. So in a certified Kubernetes admin exam context, be careful not to unintentionally block system components unless instructed. So next, the second part, now I'll be talking about the toleration, the pod part, right? So first, how to create a toleration. Let's say we need a YAML first. So we'll create a pod YAML. So k run nginx. We are using image nginx. Restart never, dry run client o YAML, and we are creating a pod YAML file. Now we'll manually edit the YAML file, and we have to go under spec section. We have to add this tolerations. So we are saying key env operator equal value equal to prod and effect equal to no schedule. And after we have made the change, we'll apply the YAML file. So you will see the immediate output saying that nginx pod created. So next I will talk about equal versus exist, which is for toleration pod, right? Operators, the two operators. So under spec tolerations, this array is flexible. The operator field dictates how the pod matches the node's taint. So first is the equal operator. So this is the default if operator is omitted. It requires an exact match of key, value and effect. So this is how we will create a toleration. So this is precise. It says I am authorized for the blue team's scheduling lock. It will not work if the node has team equal to red or just team with no value. Next one is the exist operator, and this acts as a wildcard. It ignores the value field. So here only key is required, team, operator exist, and effect is no schedule. So this says I tolerate any team constraint, whether the node is team equal to blue or team equal to red. This pod has the key. This is useful for administrative workloads like logging agents that need to run on all team nodes without managing a list of specific team values. Node conditions mapping. So this is a quick table. So when the node controller detects a problem, it will translate the node condition into a taint. So as soon as you put a taint, then the pod will not be able to be get scheduled or execution, or if it is no execute, the pod will start getting evicted from that node. Let's say you have two node, and let's say the condition that node has detected this condition, let's say out of disk, right? So it will put a taint of this, and as soon as it puts a taint and let's say no schedule, new pods will not be able to be run on that or cannot be scheduled on that node. So for example, condition ready false, so then it will immediately put not ready, no execute. So this is no execute, so immediately it will start eviction. So this is no execute, right? If the condition is unknown, no execute. So it will start evicting from let's say two node, from first node to it will go to the other node. This is for example out of disk or memory pressure and process ID pressure. Number of processes have gone very high. Disk pressure. So if the disk is under pressure, memory, this is for RAM, is for storage, and network unavailable true. So you can see this is all are no schedule. So it means from this point onwards, no new pods should be run or scheduled on that node if this condition is detected, right? And these two are no execute because it has to immediately evict those workload from here, from unhealthy node to the healthy ones. Here, this is fine if it is continue, the existing pods continue to run, but no new pod should come. That is what the intention is. Now I'll just go through the dedicated node pattern, which I talked about in my first slide. A common requirement is to ensure a pod lands on a specific node. For example, it should have a GPU label and that no other pods land there. So this requires a taint plus affinity combo, right? The triad, right? Taint, toleration, and affinity. So the first is the taint node side. So this will keep the strangers out. So we are creating a lock onto the node. So we'll say k taint nodes. This is a name of the node, right? And this is a taint specialized equal to GPU key value, and we are saying no schedule. So do not schedule existing. If it's there, it's fine. But from this point onwards, do not schedule any pod. So this is the step 1. Next is the step 2, the affinity. The pod side, this will draws the target pod in. So now we are creating a, let's say this is the same in my analogy. So this is like a magnet or a GPS. So this will guide the pod to go to this node. And third one is the toleration. So this is also pod side. This allows the target pod to bypass the taint. So we are giving a key to the pod. So we are giving a key. So it's like a magnetic key. And the key will guide to go to the tainted nodes. So exam task probably may have something like let's say create a pod ML job that runs on a GPU node. Ensure no other pods can run on GPU node. So first step we have done. So we have to run this command. So this is step 1. Now 2 and 3 will be done in one shot through the YAML file. So let's say we have a YAML manifest for the pod. This part is already there. So this is first we add the tolerations. So this will say, okay, key specialized equal to GPU no schedule. So this matches here, right? specialized GPU, no schedule. So this is the third part, the toleration. So this is like a key. Now this node may, if we don't have affinity, this node may still go to the other nodes. The node affinity part will make sure this pod does not go to the second node or the other nodes, right? So this is the node affinity part. It should go on the node which has GPU label. So we are saying required during scheduling, ignored during execution. And then we have node selector terms, so match expressions. So we are saying key specialized, so key specialized in values GPU. So this is matching, right? So this is how it will only go to the specific nodes, the dedicated nodes, right? So this is what is called as dedicated node pattern. And that's all. Thanks for watching.